All right, so this is section 3.2, and our essential question is, what are the subsets of the complex numbers? And we're first going to look in the textbook at page 103. And this goes through some of what you know and some of what will be new. When you first start working with numbers, you worked with the natural numbers, which are 1, 2, 3, 4, and so on. Then they added the whole numbers, which is simply added a 0 to that. Then they added the integers, which were the whole numbers and their opposites. Then you added rational numbers, which is anything that can be written as a fraction, a over b. And so this is things that you're fairly familiar with. The irrational numbers are like the square root of 7. There's an approximate number for that, but there's no exact number. Pi would be another one for the irrational. And all of these comprise to give us the real numbers, which is where all of your work up to this point has been with. But today we're going to add the imaginary numbers. And imaginary numbers are the square root of a negative number, like the square root of negative 4. Because there's nothing, remember the square root is what times itself gives you negative 4, and 2 times 2 gives you positive 4, and negative 2 times negative 2 gives you positive 4. So we can't deal with that. So we can by adding what's called the imaginary unit. I is equal to the square root of negative 1. Okay, so we're just going to say I, and that's equal to the square root of negative 1. And so now we can simplify this and say, well, this is the square root of negative 4 is the same as the square root of 4 times the square root of negative 1. And the square root of 4 is 2, and then we're just going to the square root of negative 1, we're going to say is I, and so that would be 2i. And all of this together combines our real numbers and imaginary numbers to give us our complex numbers, which are a combination of imaginary and real numbers. So, our objectives for today, the student will be able to define and use the imaginary unit. Remember, the imaginary unit is going to be I. Add, subtract, multiply complex numbers. And then find complex solutions and zeros. So now we're going to find solutions that have i's in them. So the imaginary unit is defined by I, which I is the square root of negative 1. So as we go into this, I equals the square root of negative 1. So if we have I squared, well, that would be the square root of negative 1 squared. And square roots and squared signs cancel each other, so I squared would be a negative 1. And then if we did I cubed, that would be negative 1 times I, so that would be negative I. And I to the fourth would be the same thing as I squared times I squared, which would be negative 1 times negative 1, so that would be positive 1. And then from there it just repeats. So I to the fifth is going to be I to the sixth would be negative 1. I to the seventh would be negative I. And I to the eighth would be 1 again. And that pattern would just repeat as we go through this. So, our core concept is the square root of a negative number. So the property, if r is a positive real number, then the square root of negative r is equal to I times the square root of r. So it's really easy. Anytime you come to a negative square root, you're simply going to bring an I out front and then simplify it from there. So the square root of 36 is 6, and so that would be 6i. If by the first property it follows that I squared r squared would be negative r. And so let's look at that. So they're saying I times the square root of r times I square root of r. Well, this gives us that I squared. And the square root of r times the square root of r, the squared and the square root cancel each other. So that would be r, and then I squared is negative 1. So we get negative r. So that's pretty easy to see. So let's look at example 1 on page 104. So if we look at page 104 and we look at example number 1. So we're just going to simplify these. So this says the square root of negative 25. Well, the square root of 25 is 5. And then again, take care of the negative sign. We just put an I in front or behind. So it would be 5i. The square root of negative 72. Now we're going to simplify this like we did on the first unit. So I'm going to break 72 into 36 times 2. Again, to take care of that negative sign, we bring the I out front. And whether you do the factor tree or break it up doesn't make any difference, but it ends up being 36 times 2, and the square root of 36 is 6. So we get 6i square root of 2. And the last one, again, to take care of that negative sign, we bring the I out front. The square root of 9 is 3, and 3 times negative 5 would be negative 15i. So, there's 3 problems. So what I'd like you to do now is to go ahead and pause the video. And do these MP problems 1 through 4, and then come back, check, see how you did. So on this one, that's the square root of negative 4. So again, when you bring the I out front, the square root of 4 is 2, so that would be 2i. Again, I just take care of it. Anytime I see that negative sign, just bring the I out front to start with. So that would just be I squared root of 12. And then I can break 12 into 4 times 3. The square root of 4 is 2, so that would be 2i. And then the square root of 3 would stay inside. The negative 36, so we bring the I out front, so negative I square root of 36, and then the square root of 36 is 6. And so you should have gotten negative 6i. 2 square root of negative 54, again I'm going to bring the I out front first. And then we have to break 54 down, and that breaks into 9 times 6. The square root of 9 is 3. Now when you take that square root of 9 and you multiply it by what's out front, so 3 times 2i, you should have gotten 6i square root of 6. So, hopefully that makes sense. You simplify it just like you did before. The only thing that changes is when I have a negative inside the square root, I bring an I out front and then work from there. So, a complex number written in standard form is a plus bi, where a and b are real numbers. The a is the real part, so this a here is the real part of the problem, the complex number, and the bi is the imaginary part. And if you have part real and part imaginary, we call that a complex number. If b is not equal to 0, then a plus b is an imaginary number, because we have this here. If a equals 0 and b is not equal to 0, then a plus bi is a pure imaginary number. Meaning that when I have a plus bi, if I just have bi, then it's pure imaginary. There's no real part to the problem. Where here there's a real part and an imaginary part, which gives us the complex numbers. So, today you're going to do some, I think you'll find fairly easy things to do. Operations with complex numbers. We're going to add and subtract complex numbers. So to do that, you add or subtract the real parts, and then you add or subtract the imaginary parts. So as an example here, just with no numbers, if I have a plus bi times c plus di, I add the real parts, the a and c, together to get a plus c, and then I add the imaginary parts, the bi plus di, which gives me the imaginary part. Same thing with subtraction. The thing you have to be careful of with subtraction is, remember this subtraction, I would change it to addition and change both those signs. So it would be a minus c and bi minus di, which would be b minus di. It'd be a little easier as we look at numbers. So if we have, let's say 4i plus 7i, actually, let's take 3 plus 4i plus 7 plus 5i. So I add the real parts. The 3 plus 7 gives me 10. And the 4i plus 5i gives me 9i. So you add them just like if those were x's. It doesn't change anything when we're adding. Same thing if we subtract. If we take the same exact terms, but now we subtract them. So again, my suggestion is change the subtraction to addition, and then you're just adding like you did before. So 3 plus a negative 7 equals negative 4, and 4i plus a negative 5i would be a negative 1i, or just negative I. So let's look at example 3 in the textbook. So we're going to add or subtract whatever it is. So this first one is addition. So again, we add the real parts. 8 plus 5 is 13. Negative I plus 4i would be plus 3i. The next one, 7. Now this is minus, so again I'm going to change that to addition and change both signs. So 7 plus a negative 3 would be 4. And negative 6i plus 6i would be 0, so I don't need to put anything down. And then this one's a little bit different. It's just expression that we have to simplify. Again, it's minus in front, so I change it to addition, change those signs. It doesn't change the 5i because that's outside the parentheses. So now combine like parts, so we have 13 plus a negative 2, which would be 11. And then we have a negative 7i plus 5i, which would be a negative 2i. One other thing I'd like to look at on this was up here at the top of this. They're going to give you some problems like these, where they ask you to find the values of x and y that satisfy the equation. Well, this is an equal sign. So if both sides are going to be equal, the real parts have to be equal and the imaginary parts have to be equal. So if I look at this, it says x plus 3i equals 9 minus yi. Well, the real parts are the parts without an I. So the x has to equal 9. And then the 3i has to equal the imaginary part over here, which is negative yi. So we have 3i equals negative yi. Well, the i's are already the same, so that would tell us 3 has to equal negative y, and so negative 3 would have to equal y. And if we look at this one, the real part, 9 plus 4yi equals negative 2x plus 3i. So the real part, 9 has to equal negative 2x. So we divide by negative 2. So negative 9 halves equals x. And over here, the imaginary part, 4yi, has to equal the imaginary part over here, 3i. Again, we can just cancel the i's by dividing by I on both sides. So then divide by 4, and so y would equal 3/4. So they're a little different, they're not hard, but it's just a little bit different format. Just make the real parts equal to the real parts and the imaginary parts equal to the imaginary parts. Now let's look at example number 4. So, example number 4 is solving a real-life problem. Where imaginaries come into play a lot is with electricity, because we have to take square roots of negative numbers. And so a lot of story problems I'll give you with imaginary problems involve electricity. And so it says the electrical current circuit components such as resistors, inductors, and capacitors all oppose the flow of current. Okay, so they restrict it. This opposition is called resistance for resistors and reactance for inductors and capacitors. Each of these quantities is measured in ohms. The symbol used for ohms is the Greek uppercase omega letter. So, here's the component in the symbol. So the resistors on this are going to have these squiggly lines. So this would be the resistor here. The inductor is going to have this symbol. and the capacitor will have this symbol. And so it says the table shows the relationship between a component's resistance or reactance and its contribution to the impedance. A series circuit is also shown with the resistance or reactance of each component labeled. The impedance for a series of circuit is the sum of the impedances for the individual components. Find the impedance of the current. So it tells us that we're going to take the sum of the impedance to get the total impedance for the circuit. And so if we look at the example, the solution, it says the resistor has a resistance of 5 ohms. Okay, and they put that in this box, how they're using it to diagram it up above here. So its impedance is 5 ohms. The inductor has a reactance of 3 ohms, so its impedance is 3I. So when you come to the inductor, you're always going to put an I with it. So in this case, this is going to be 3I. This is still just going to be 5. And the capacitor has a reactance of 4 ohms, so its impedance is a negative 4. Because it takes away from it. So to find the total impedance, we just add those up. So it's 3I plus 5 minus 4I. And so again, we can only add the real parts, so that would be 5. And then 3I minus 4I would be a negative I, and that would be our total impedance. Excuse me. So, the next thing we're going to do, we're going to multiply two complex numbers. Again, remember that I squared is a negative 1. So let's just take 3 plus 4I times negative 2 minus 5I. So we just FOIL this or claw it, whatever method you prefer. So I take 3 times 2 is 6. 3 times the negative 5I is negative 15I. 4I times the negative 2 is a negative 8I. And then 4I times the negative 5I would be a negative 20. And then I times I is I squared. But remember, I squared is a negative 1. So this becomes negative 20 times negative 1, so that becomes plus 20. And now we just combine like terms to simplify this. 6 plus 20 is 26. And then negative 15I minus 8I would be a negative 23I. And we're done. So it's really not complicated. You do the FOIL method just like you've always done. The only difference is this I squared is going to become a negative 1 so when you go to simplify. So if we look at example 5 on page 106, two examples here. This one says 4I times negative 6 plus I. So again, we just distribute that. 4I times negative 6 is a negative 24I. And then 4I times I would be 4I squared. But I squared is a negative 1, so that would become negative 4 minus 24I, and I'd be done. The second one, we FOIL this. So let me write this so you can see it. 9 minus 2I, negative 4 plus 7I. So 9 times negative 4 is negative 36. 9 times 7I is a positive 63I. Negative 2I times the negative 4 would be a positive 8I. And negative 2I times a positive 7I would be a negative 14I squared. I have to remember that I squared is negative 1, so that becomes negative 14 times the negative 1, which becomes positive 14. And so now if I combine like terms, I have negative 36 plus 14 is a negative 22, and 63 plus 8I is 71I, and we're done. So, if you would now go to the textbook, page 106, and try numbers 7 through 13 on the MP problems, and just make sure. Again, do enough that you feel like you understand it. If it makes sense, then go ahead and not do them all, because there's quite a few here. But there are some addition, subtraction, and some multiplication, so you're probably going to want to do most of those. But take a look at it, pause the video, come back, check, see how you did. So if you look at this, on this they're just asking, what if we replace, it says, what if the impedance of the circuit when the capacitor is replaced with one having a reactance of 7 ohms? So if we go back up to this problem, what they're asking is, what happens so they're asking, what if the reactance is changed to 7? And in this one, our reactance was 3. So now we're just changing this to 7. And so now again it would just be 3i plus 5 minus 4i. And so that would be 5 minus, oh excuse me, this would be 7i. So that would be 7i minus 4i would be 3i plus 5. Or 5 plus 3i, doesn't make any difference what order you do that in. So I'll just go through these up here so you can see them. Number 8 said 9 minus I plus negative 6 plus 7i. So again, it's addition, so we just add the like parts. 9 plus a negative 6 is 3. Negative I plus 7i is a plus 6i. Number 9, 3 plus 7i minus 8 minus 2i. So again, I'm going to change this subtraction to addition, change both signs. And now it's an addition problem, so 3 plus a negative 8 is negative 5, and 7i plus 2i is 9i. 10 is negative 4 minus 1 plus I, and then minus 5 plus 9i. So again, these subtraction signs in front of the parentheses, I'm going to change it to addition, change the signs, change it to addition, change the signs, now combine like terms. So I've got negative 4 plus negative 1 is a negative 5, plus negative 5 would be a negative 10. And then negative I plus a negative 9i would be a negative 10i. And we're done. Now let's look at 11. Eleven says negative 3i times 10i. So again, you treat this just like they're x's. Negative 3i times 10i would be a negative 30i squared, but I squared is a negative 1, and negative 1 times negative 30 would be positive 30. So that I squared just changes the sign. If we look at 12, it says I times 8 minus I. Distribute the I, so we get 8i minus I squared. Again, that I squared is a negative 1, so the opposite of negative 1 would be 8i plus 1. And then the last one, 13, 3 plus I, and then 5 minus I. So we're going to distribute this. 3 times 5 is 15. 3 times negative I is a negative 3i. I times 5 is a positive 5i. And negative I, or I times negative I would be a negative I squared. So this is going to become a positive 1, because you have a negative 1 times a negative would be positive. So 15 plus 1 is 16. And negative 3i plus 5i would be 2i. So let's take a look at example 6. Solving quadratics. So we just did this on the last chapter. The only difference now is we're going to add imaginaries. So this first one says x squared plus 4 equals 0. So from the last section we know that we want to isolate the part that's squared. So I'm going to move the 4 over by subtracting 4. And so nothing changes from what we did before. Now we take the square root of both sides. So we're taking the square root of -4. The only difference is on this assignment you're going to get some negative numbers. So the square root of -4, again when you're solving it's always plus or minus 2i. So let's look at the second one. We have 2x squared minus 11 equals -47. So again, we have to isolate the part that's squared. So we have to get this x squared by itself. So we add 11. So we get 2x squared equals -36. We divide by 2. We get x squared equals -18. And then we take the square root of both sides. And so x equals 18 I can break into 9 times 2. The square root of 9 is 3. To take care of that negative sign, remember, oops. So it's plus or minus 3i, and then the square root of 2. So you won't have your answers in with negative. When it says to find the zeros, when it says to find the zeros of a quadratic, again, that's just like the last time. It's just going to be say find the zeros of f of x equals 4x plus 20. So that just means you set it equal to 0, just like we did in section 3.1, and we find the zeros. So again, get the part that's squared by itself, so we subtract 20, and we get 4x squared equals -20. We divide by 4, so x squared equals -5. Then we take the square root of both sides, so x equals plus or minus. Again, take care of that negative sign, just bring an I out front. So nothing changes from what we did before. The only difference is we're taking square roots of negative numbers. So I'd like you to go through and try the MP problems 14 through 22 on page 107. So go ahead and try those, then come back, check, see how you did on them. Again, if you feel like you've got it, you don't need to do them all, but do enough that you're sure. If you want to skip around, that's fine. But you can come back, check the video out, see how you did. So I'll just do these off to the side here. So 14 said x squared equals -13. So pretty easy. The x is already, the part that's squared is isolated. So we take the square root of both sides. And we get x equals, to take care of that negative side, I, again, sorry about that, plus or minus because it's in an equation, square root of 13. 15, x squared equals -38. So I take the square root of both sides. So we get x plus or minus I. There are no perfect squares in 38. You can break that into 2 times 19, but you don't get any pairs. So that would just be the square root of 38. If we look at 16, x squared plus 11 equals 3. So again, the part that's squared is this. We have to isolate that, so we're going to subtract 11. We get x squared equals -8. Take the square root of both sides. So x equals plus or minus 8 can be broken into 4 times 2. The square root of 4 is 2, so we get 2i, and then square root of 2. So 17, x squared minus 8 equals -36. So again, we have to isolate the x squared. We add 8 to both sides. So we get x squared equals -24. Take the square root of both sides. So we get x equals plus or minus. 24 I can break into 4 times 6. The square root of 4 is 2. So that's 2. Again, we bring the I out, take care of that negative sign. And then what's left is the square root of 6. 18. 3x squared minus 7 equals negative 31. Again, we have to get this x squared by itself, so we add 7. 3x squared equals negative 24. Divide by 3. X squared equals negative 8. And we've already just did that a little bit ago. Square root of negative 8 would be plus or minus 2i square root of 2. So that's 18. 19. 5x squared plus 33 equals 3. Again, we have to get this by itself, so we subtract 33. 5x squared equals negative 30. Divide by 5. X squared equals negative 6. Square root of both sides. Plus or minus, there are no perfect squares in 6, so just I square root of 6. And then the last 3, again, it's the same thing. It's just written in function notation. So if you look at 20, it said f of x equals x squared plus 7. But again, we're just trying to find the 0, so we don't know what makes this equal to 0. And so now it's just an equation, just like the others. So we subtract 7. X squared equals negative 7. Take the square root of both sides. So x equals plus or minus the square root of 7. Excuse me, I square root of 7. Got to remember to pull that I out with for the negative. So on all of these, you can just write it. When you write it, number 21, you don't need to put the f of x. You can just put negative x squared minus 4 equals 0. So we add 4. We get negative x squared equals 4. Again, we got to get that x squared by itself, so I have to get rid of that negative sign, so I'm going to divide by negative 1. So I get x squared equals negative 4. Take the square root of both sides. So we get x equals plus or minus the square root of 4 is 2. And we have the I to take care of that. The last one. 9x squared plus 1. Again, we want to know the 0, so what makes that equal to 0? We subtract 1. 9x squared equals negative 1. So we divide by 9. So we get x squared equals negative 1/9. Take the square root of both sides. So x equals plus or minus. Now, again, we bring the I out to take care of that. When you do square roots of fractions, remember you can just break it down into the square root of 1 over the square root of 9. The square root of 1 is 1, and the square root of 9 is 3, so it would be plus or minus 1/3 I. So we went through lots of examples on this. Again, it's really, the only change is we've got this square root of negative numbers, and we handle that by bringing an I out front. And then you have to remember that I squared is a negative 1. Other than that, it's no different than 3/1. So, your assignment is page 106, 561, the odds. That will be on the big ideas. And hopefully this makes sense.